Alright, so in this video, we will be going over the coding part of this solution, and I discussed the visual representation of the problem and how we have to approach it. So basically, we are going over each of these boxes. So we'll obviously be, and since we have been given vectors, so we can go over this approach. We'll be traversing it using DFS. So I'll show you the first approach, which is the DFS approach, and then I'll be talking about the BFS approach. So let me just comment out this BFS approach first. So as you can see, the function that was given to us is maximum candies. So this is the function maximum candies, and we have status of the box, whether it's open or closed. So if it is open, then it would be marked as 1, and if it is closed, it will be marked as 0. So this is that vector. Then we have the candies vector, the number of candies in each box. The keys vector, the keys that we have for opening the box. This is a vector type, so basically it is of this format, right? And this too, contain boxes, is also of this format. Contain boxes basically is, let us say we have this box, then just like the analogy of a Russian doll, we have another box present inside this box, right? And there may be more boxes present inside the bigger box. So that's that. And we have finally the initial boxes, that is the boxes that we have open initially and that may have candies or may not have candies, right? So firstly, I've set the variable answer, which will be our total number of, or the maximum number of candies that we can have. So this is the answer variable, and I have made two sets, visited and found boxes. So visited will be used because we are applying DFS, and once we have visited a particular box, then we won't have to have the need to revisit it again. So that is why visited, and this is of the format set. Then we have we basically go over all the boxes and add all the candies that we are receiving from this DFS function. So this is our main function DFS, and we return the answer, which is the maximum number of candies. So DFS is our main function, and it takes the box and vectors and vector types, which are matrices. So firstly, we check if the box that we are considering, whether it has already been visited or not. So if visit.countBox is equal to 1, if it has already been visited, if that box is already visited, then we won't have the need to visit it again, because the candies from that box have already been considered. So we cannot get any more candies from this box. So that's why we return 0. Now, if status of box is 0, that means if the box is closed, if it is not yet open, we cannot get any candies from here, because this box is closed and we haven't found the key for it yet. But since we haven't found the key for it yet, there is a possibility that later on, when we visit the vector, we might find the key for this particular box. So we can open it later on. So that is why we need to mark it for future, that we have found this box, and once we find the key, we'll go back to that box and open it and get the candies from it. So right now we're returning 0 because we cannot get any candies from here. So no candies means 0 candies here, and we include it into the found boxes unordered set. Next up, we basically just mark this as visited because we've already visited it, and we take a variable candies from box. This would basically count the candies, and we get the candies from box. And now we go over contained boxes. So basically, for example, the example that we chose, this is the box 0, and it had 1 and 2, right? So this is 0 and this is 1 and 2. So these are the contained boxes of 0. So we're going over the inside boxes, that is, we are considering 1 and 2, right? As I've shown you here, right? So this is the example. So this is the box label 0, and these are the contained boxes 1 and 2. So these are the inside boxes. So for each inside box, we're basically going to be adding the candies that we receive from it, and this is basically the recursive call that we use in DFS. Similarly, for in box key in keys of box, so we now check for the keys found in box that can open up other closed boxes that I discussed earlier, right? So once we find the keys, we mark that box as open, so we mark it as open, and also add it to the found boxes, right? If we have already, we check if we have already seen the box earlier, that is, if it is found in the found boxes vector, unordered set. If we have already seen it, then we open it and get more candies from it. So then we basically again call it recursively, and this completes the function, and then we return candies from box. So that is about the DFS approach, and in the next video I'll be going over the BFS approach.